Okie dokie. So the plan here is to work out how to interpret the gradient of a linear equation or graph. And there's kind of two ways that a linear equation will represent things. First off, the gradient, or should I say the gradient of a linear equation will represent things. The first off is it might represent a ratio, and the second is it might represent a constant rate of change. So we're going to have a look at examples of each. So the first question I'd like to ask you is, which animal could this red line represent? Have a think about it for a second. You can pause the video if you want, but here's how we could think about it. So if we had two of the animals, this is number of animals, this is number of legs. If we had two of the animals, we would have 4 legs. If we had 4 of the animals, we would have 8 legs. So let's just have a think about those numbers. So animals and legs. If we had 2 of the animals, we would have 4 legs. If we had 3 animals, we looked at 4 and 8. 4 of the animals, we'd have 8 legs. So legs per animal equals, we could look at this number, we could say 4 over 2 equals 2 legs per animal. Or alternatively, we could use this set of numbers and we could say legs per animal equals 8 over 4, which also gives us 2 legs per animal. So this is an example of gradient as a ratio. We've got, for every animal we've got, one animal, we've got 2 legs. So what could it be? Well, maybe one of these ones. Or one of these ones. Or a monkey or something. Great, so what about this line? Which animal could this blue line represent? Well, again, we can kind of say, well, if we had 2 of them, we'd have 8 legs. If we had 4 of them, we'd have 16 legs. Animals, legs. If we had 2 animals, what was it? If we had 2 animals, we'd have 8 legs. If we had 4 animals, we'd have 16 legs. So legs per animal equals 8 over 2 equals 4. Or we could use these numbers. 16 over 4 again equals 4. So one animal will have 4 legs. Again, ratio. What animal could this be? Well, probably some generic animal that looks something like this. Maybe it's a cat. Maybe it's a lion. Anyway. It's got 4 legs. What about this final animal? Which animal could this green line represent? Well, 2 of them. We've got 16 legs. One of them, 8 legs. Well, that's an easy way of doing it, isn't it? One of them, 8 legs. So, legs. It's not a very good legs. Legs per animal equals 8 over 1 equals 8. Or the other numbers we had was 16 over 2 equals 8. 8. So, one animal has 8 legs. What could it be? That's an eye. That's an eye. Spider. Anyway, I don't know how to draw a spider. That's a web. Or maybe it could be an octopus. 1, 2, 3, 4, 5, 6, 7, 8. Who knows? So that's interpreting the gradient as a ratio. And we could have other things as well. Maybe we could have something along the lines of, feet, and toes. If we had 1 foot, how many toes would we have? 1, 2, 3, 4, 5. If we had 2 feet, how many toes would we have? 5, 6, 7, 8, 9, 10. If we had 3 feet, we'd have 15, and we'd end up making a straight line. It goes like this. What's the problem with my straight line though? It needs to go through 0, because if you don't have any feet, you're not going to have any toes, hopefully. It's going to be a straight line, which means that this is going to be about 15. So that's a ratio. In this case, toes to feet. Now for a key. When trying to understand linear graphs, think about the units of the gradient. What do I mean by that? Well, I mean units of gradient is units of rise over units of run. The rise is always the y-axis, rising up. So in this case, we've got legs, and the run is always the x-axis, going across. So in this case, our rise over our run, our units of rise over run gives us our number of legs divided by our number of animals, which we can think of as this line as per, so legs per animal. So let's look at another example. So that was looking at interpreting it as a ratio. Now we're looking at it as a constant rate of change. So you may remember Sam and Simone, the sloths from before, and they were walking north and leaving from their tree. The question is, determine the gradient of the red line. So gradient, if you recall, we can say gradient equals rise over run. Well, the way I actually like to think about it is for every step to the right in x, for every one step, how many steps do we go up in y? And I'll save that off to the side because I think that's kind of a pretty key point. Okay, so the gradient of the red line, well here, one step would be that far, one step to the right. For every one step in x, how many do we go up in y? So every one step in x, we go here, we go one step across, we go up from 4 to 5, then from 5 to 6. So the gradient of the red line is 2, right? Write a sentence to describe what this gradient means. Well, gradient, let's get a pen back. So, gradient of red line is 2. So that's our information. So we can say for every minute, this, well, if you weren't here for the previous example, we can say for every minute, the person, or in this instance it was a sloth, moves 2 meters north. So for every minute, this is 1 minute, 2 minutes, 3 minutes, the sloth, these are sloths walking, moves 2 meters north. Determine the gradient of the blue line. Well, for every minute, the sloth moves 1 meter north. Meters, minutes, meters. Write a sentence. Well, we can just say it. For every meter, for every minute that passes, the sloth moves 1 meter north. So trying to understand linear graphs, I think that kind of sounds a bit weird though, doesn't it? If we say gradient of the red line is 2, for every minute the person moves 2 meters north, it's a bit weird. We need to think about the units of gradient. So in this case, the units of gradient would be the units of rise over the units of run. And what are the units of rise? Well, units, in this case, of rise equals meters. Units of run across equals minutes. Right? Therefore, units of rise over units a run equals meters per minute. So that makes more sense, doesn't it? So we could change our sentence to say sloth going 2 meters per minute, which is a speed, which is a velocity, meters per minute. So that's pretty much what we're doing when we're interpreting these graphs. We're looking at the units of the y-axis over the units of the x-axis. So a couple of more examples. If we had distance in kilometers and time in hours, we would have, what would be the gradient of this line tell us? Well, it would just tell us kilometers per hour, wouldn't it? Kilometers per hour, a speed. What about this one? Total cost in dollars over number of lollipops. Well, it would be dollars per lollipop. That would be our gradient, units of our gradient. And finally, score in maths test, hours of study. This would be score per hours of study. And whilst these previous two, the total cost per number of lollipops and the distance in kilometers per time in hours, are more constant rate of change, this one's more a ratio. It's saying if you do this many hours of study, it's more likely to be associated with a higher score on your maths test. So that's pretty much what we've done. Understanding gradient. I hope you found this helpful.